So with implicit differentiation, you're able to take derivatives of things that are just not in the form of y equals. Is there any in particular, before I start pulling problems out, that you would like me to go through? All right, if we take a look at problem number 5. Let's go to number 6, just for giggles. Number 6. If you have not done this, you should be doing it with us. Problem number 6. We have 5y squared is equal to 3 plus 2xy. Hopefully that's the right problem. Okay, we are going to take the derivative of this, and what we have is we have two terms that involve y. Okay, we have two terms that involve y here, and then we also, with the second one, we have two terms that are being multiplied together. So we have to use our implicit differentiation, and we're going to also have to use our product rule with the second one. So if we take a look at 10y squared, and we implicitly differentiate 5y squared, Liam, what do you come down to?
10y dy dx.
dy dx is equal to, now we have the derivative of the constant, which is going to give me 0, plus then we have to deal with this product rule. So we have the derivative of the first times the second, plus the first times the derivative of the second. So running this through the product rule. Ozzy, what do we have? What's the derivative of the first?
2.
2 times y plus, then what?
2x plus dy over dx.
Okay, that's multiplied by dy dx, not times. Okay, because we have the derivative of the first times the second, plus the first times the derivative of the second. Okay, so we have the derivative of the first, which is the 2y, times the second, or 2, which is then times the y, plus the first, which is 2x, times the derivative of y, which is dy dx. So combining these together, we have 10y dy dx. Now what we need to be able to do is take this and over to the other side, because we need to bring the dy dx's together. So we can subtract off the 2x dy dx, and this is equal to 2y. So we want to combine on the same side of the equal sign the dy dx terms. Next step is to factor out that dy dx. So we can factor this out of both my terms, and I don't want to take anything else out with it, because I want to ultimately solve for the dy dx. Target. So we have dy dx, 10y minus 2x is equal to 2y. Just taking the dy dx out of both of the terms. Our last step, what do we have to do to both sides in our last step here? Adam, what are we going to do to both sides in this last step? We want to solve for dy dx.
Divide by the quantity of 10y minus 2x.
So we're left with dy dx is equal to 2y over 10y minus 2x. Now, we have three entities here. We have a 2y, we have a 10y, and then we have a 2x. Okay, we can look to see if we can cancel something out of all three of these terms. Out of the 2y, the 10y, and the 2x. But we have to be able to take the same thing out of all three of the terms. And what we can take out of all three of the terms is the value of 2. So we're left with y over 5y minus x. If we take a look at 7, we have sine of 3y is equal to 5x squared plus 7. So we take a look at the sine of 3y. We have to take the derivative of the sine of 3y. Well, we have the sine of 3y. Taking the derivative, Brandon, what do we have when we take the derivative of sine of 3y?
You get the cosine of 3y times 3 dy dx.
And then on the right-hand side, what do we have?
10x.
This is the value of 10x. Okay, we take the derivative of the trig function first, which is the sine, so we get a cosine. Then we go inside and take the derivative of 3y. Derivative of 3y is 3 times 1, which is 3, and then a dy dx. Now we can combine, or we can divide both sides by this 3 cosine of 3y, 3 cosine of 3y. So we're left with dy dx is equal to 10x over 3 cosine 3y. We take a look at number 8. When dealing with the quotient rule, that tends to give us the one that we have to work on a little bit more. As I've talked about numerous times in regards to upper level mathematics, you have to have patience as you work through the problem. So we have 10x plus 3, all to the third power, is equal to 5y squared over 4x cubed. As you work through the problem, have patience. We take the derivative of the left-hand side. The left-hand side, we have to use our chain rule. So using our chain rule on the left-hand side, Carmela, what do you have?
3 times the quantity 10x plus 3 squared. Oh, times 10.
Times 10. Okay, using our chain rule. Use our exponent. Our exponent gets stored out front. We drop our exponent by 1, then we go inside, take the derivative of 10x plus 3, which is just the value of 10. On the right-hand side, we have two values that are being divided. So we need to apply our quotient rule. Our quotient rule, derivative of the top times the bottom minus the top times the derivative of the bottom over the bottom squared. Once again, this tends to get algebraically a little bit muddier. But if we take a look, let's just go through. Once again, have patience. The derivative of the top. Bailey, what do you have with the derivative of the top?
10y dy dx.
And we multiply that by the bottom, 4x cubed, minus the top, times the derivative of the bottom, which is what?
12x squared.
12x squared. And this is over our bottom squared. And if you want to do some mental math, you've done enough of these already. You could do some mental math. I'm squaring the bottom. But if you don't want to, that is fine. You could write it as 16x is 6, but or you can write it as 4x cubed squared. Once again, the problem now becomes an algebraic problem that's you have to deal with the dy dx, and once again, you have to deal with some patience with this. Doing some simplification, this gives me on the left-hand side 30 10x cubed, or 10x plus 3 squared. On the right-hand side, we can combine the 4 and the 10 together to give me 40 yx cubed minus 60 y squared x squared, and this is over 16 x to the 6th. Oops, I forgot my dy dx in there, didn't I? So we have 40 yx cubed dy dx minus the 60 y squared x squared. Now, before we do anything else, what I would tend to do is I would tend to look to see what can we take out of all my 3 terms up there. Okay, I have 3 terms, 3 entities. I have the 40 yx cubed dy dx. I have the 60 y squared x squared. Then I have a 16x to the 6th. What can we take out of all 3 of our terms? Evan, what can we take out of all 3 of our terms?
4.
Take a 4 out. Okay, so that would give me 4 here, 10 here, 15 here. What else?
And an x squared.
And x squared. So that would take care of them. This would drop to 4, and this would go to 1. So we have 30, 10x plus 3 squared is equal to 10 yx dy dx minus 15 y squared over 4x to the 4th. Okay, solving for dy dx. I got a bunch of stuff that's connected to the dy dx. The first thing we have division by 4x to the 4th that we can multiply to both sides. Which will cancel these out. So this gives us 120 x to the 4th, 10x plus 3 squared. And this is equal to 10. I'm going to switch those around. xy dy dx minus 15y squared. Next thing, we can get rid of the 15y squared by adding that to both sides. So let's add the 15y squared to both sides. So we have 120 x to the 4th, 10x plus 3 squared plus 15y squared is equal to 10xy dy dx. And the last thing we can do is get rid of that multiplication by 10xy by dividing both sides by 10xy. Once again, we have entities that we can do some division. We can take a 5 out of all these. So this gives me 2, this gives me 3, and taking 5 out of that would be 24. So we're left with 24x to the fourth, 10x plus 3 squared plus 3y squared over 2xy. Phew. A lot of work. And most of the work is not really derivative oriented. It is more trying to get it to solve for dy dx. So we have to do a bunch of work to solve for that dy dx. If you take a look at problem number 10, it says determine the equation of the tangent line to the graph of the equation at the given point. Now what I gave you is I gave you a point at 1, 2. We have x cubed plus 10xy is equal to the value of 5. And we're looking at the ordered pair 1 and 2. Now, when we're dealing with the implicit differentiation, I have to give you that point of tangency most of the time, just because sometimes it's not an easy thing to be able to see what our point of tangency is going to be.
Mr. Gregory,
Yeah.
our problem says 2xy, not 10xy.
It gives you what?
It says 2xy.
Yeah, mine does too. I don't know why. Must be my old man technology in my eyeballs. There, is that better?
Yeah.
You know what's simple? I'm still somewhat amazed at I'm able to write on here and talk, and you can sit there at home and see everything actually in the actual time that's happening, and there's no lag at all or anything like that. To me, that's sort of amazing as an old person. Anyways, thank goodness Google didn't stay down. Okay, we want to find the equation of the tangent line at the given point, 1, 2. Well, to find the equation of the tangent line, I need to find a slope. Well, to find my slope is defined to as my derivative at the ordered pair 1, 2. So we need to determine our derivative at the value 1, 2. So if you've not done it, please take your derivative and implicitly differentiate this. And once again, don't forget, we're going to have to use our product rule with the 2x and the y. Go ahead and take your derivative. Dylan, if we implicitly differentiate this, what do we get? Don't worry about simplifying yet. What do we get here when we implicitly differentiate?
I got dy dx equals
Just don't go back. Take it one step back.
the derivative.
Yeah, just what your derivative is right now. If I would use my product rule.
Okay, I got 3x squared plus 2y plus 2x dy dx equals 0.
Equals 0. Okay, now what do you get for dy dx?
Minus 3x squared minus 2y over 2x.
Okay, that's correct. So now we can sub in our values for x and our values for y. So in for my x, I'm putting in a value of 1. In for my y, I'm putting in a value of 2. So in for x, I'm putting in 1. In for y, I'm putting in a value of 2. Liam, what do you get for your slope? Liam?
-7/2.
Negative 7 over 2. We get negative 7/2. So now we have our slope, and we have our point that we're going through. We can put in negative 7/2. X minus 1 is equal to y minus 2. And once again, I will accept either form of our equation. I would multiply by 2, negative 7x, and distribute my negative 7 through. Negative 7x plus 7 is equal to 2y minus 4. So we have 7x plus 2y would equal a value of 11. Or y would equal negative 7 over 2x plus 11/2. Once again, either one is acceptable in the solution. Any other questions that you have? All right, you have in your packet implicit differentiation 2, just additional practice with respect to implicit differentiation. I would like you to take the rest of the time to be able to work on them. Wednesday, once again, will be a review day. I'll get you a review sheet for you. I think I have it in the packet already. I hope. So we will have a review day, and then Friday we will do the quiz over implicit differentiation and dealing with the chain rule and implicit differentiation. Yeah, there's a review sheet in there that will involve what we've been talking about. And then we'll take the quiz on Friday. Questions that you have? Okie dokie, that's all I have for you today. Please use this time that I give you at the end to be able to work on the problems from the worksheet. And once again, I'll see you on Wednesday with the review sheet that's also in your packet. We'll go over any questions that you have. It should be a short day on Wednesday. It should be a short day Wednesday and Friday also in here because you'll be taking the quiz on Friday then. All right, there's no questions. If you do have a question, you can hang around afterwards and ask this. If not, adios. I'm done for the day. Have a good day, everybody.